folks, Miss Wilson here to help you with another math problem, hopefully. So what do we have here? We've got fractions. Don't freak out. It's okay. We can handle fractions. Notice we have a term in here. We got 1/2 j squared. Actually, honestly, this is all one term because it's all multiplication, but it needs simplifying. And we have in parentheses a 1/2 j squared, but all of that is raised to the 5th power. And then over here we have a 2/5 j to the 3rd squared, and you see that's all raised to the 2nd power. So I need to handle that first. Now whenever you have multiplication or division inside an exponent on the outside, that exponent applies to everything inside. So what I'm trying to say is this 1/2 must be raised to the 5th power, and this j squared must also be raised to the 5th power. We will simplify that more in a second, but let's move on to the second polynomial we have. Notice again the set of parentheses means the 2/5 is raised to the 2nd power, and the j to the 3rd is also raised to the 2nd power. So I have 2/5 to the 2nd power, and I have a j to the 3rd to the 2nd power. Now, how do I handle these fractions raised to a 2nd power? Now, over here to the side, when you have 1/2 to the 5th, and what that really is 1/2 times 1/2 times 1/2. You guessed it, 5 times. And to multiply fractions, you say 1 times 1 times 1 times 1 times 1 is 1 in the numerator, and 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 in the denominator. But I can go ahead and tell you, whenever you have a fraction, really what you're doing is you're saying the numerator is to the 5th and the denominator is to the 5th. That's a faster way of getting there, takes less space, okay? Or you don't even have to write it down like that. You can just jump down here and say 1 to the 5th is 1 and 2 to the 5th is 32. Not 10, right? 2 to the 5th is 32 because it's 2 times 2 times 2 times 2 times 2, 5 times. Okay? Now, j squared to the 5th. And you've seen this property that says when you have a power to a power, you multiply those together. Okay, now notice that's different than, look at the top right here. If I said j squared times j to the 5th, that's when you would add them together. That is j to the 7th, but that is different than j squared to the 5th. In that case, you multiply them together to get j to the 10th. So that is going to be j to the 10th. Okay, now here we are again with a fraction raised to a power right here. So we just learned that I can say that's 2 squared, or 2 times 2, which is 4, and 5 squared, or 5 times 5, which is 25. And then right here, I multiply those together to get j to the 6th. Now we're not finished because I'm required to multiply this fraction times this fraction, and then the j to the 10th times the j to the 6th. Now, I think before I multiply these together, I'm going to group them together. So I'm going to put my fractions together, and then my j to the 10th times j to the 6th, put those together. The reason I'm doing that is because when you multiply fractions, you multiply numerator times denominator, it'll get 4 on the top, and denominator times denominator, which is going to be big on the bottom. But you know what I can do? I can cancel this 4 and this 32 because we know 4 goes into 4 one time, and 4 goes into 32 8 times, and that way my numbers don't get so large. So now I say 1 times 1 is 1, and 8 times 25 is 200. And then j to the 10th times j to the 6th is going to be j to the, remember you add those together, so it's like this rule right here. It's going to give me j to the 16th. So there's 2 ways you can write this answer. I think that is absolutely fine. Honestly, if you type this into Newton Alta, I'm not exactly sure which way they'll want it. They should give you credit for both, but I'm not going to promise you anything. Also, j to the 16th over 200, do you see that's correct as well? Because if I multiply 1 times j to the 16th, that's j to the 16th, and then 200 times the 1 in the denominator here is 200. Both of those are perfectly acceptable answers, and I'm crossing my fingers that if you type that in Newton Alta, it would also give you a correct answer for both of these. Hope that helps you out.